Welcome to week 3. I'm gonna record the practice quiz. So we're gonna use this file, the practice quiz, and also we're gonna use the formulas for chapter 6. So week 3, we're doing chapter 6 from the book. Okay, so let's start with these are the files I have open. This is the practice quiz, starting from number 1. And also we have, this is the formula sheet for arithmetic, geometric sequence, and series. You have the formulas included, the sum. So these are the formulas we're going to use. So let's start with number 1. In number 1, we have for the following sequence whose general term is given, we have to find the first 5 terms. So here we have to find the first 5 terms, and this is the general term. So usually for questions like this is how I'm showing you my work. I can just pick n is changing from 1 to 5, and we did this in algebra, same type of questions. Okay, and we have to calculate each term. So when n is 1, 2, 3, 4, and 5. And this is the formula. The formula is 3 with exponent 2n minus 3. And then you're going to start calculating. So first, when n is 1, you're going to substitute in this formula. N is 1, we'll have 3, 2 times 1 minus 3. So that will give me 3 with exponent 2 times 1 is 2 minus 1 is negative 1. 3 to the negative 1 exponent is going to be 1 over 3. So that's my first term, 1 over 3. Then the next step is we're going to replace n with 2. So we're going to have 3 with exponent. 2 times 2 is 4 minus 3 is going to be 3 to the first exponent, the first power. So my second term is just the 3, the number 3, because 3 to the first power is just 3. I'm just going to put this to kind of separate the work. Okay, then I'm going to plug it in. N is going to be 3. So I'm replacing in this formula. N is 3. So I have 3 with exponent 2 times 3 minus 3. So 2 times 3 is 6. 6 minus 3 is 3. So I have 3 cubed, which is 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. So my next term is going to be 27. And then I'm going to go to the next one, which is n is 4. So I have 3 to the power 2 times 4 minus 3. 2 times 4, 8 minus 3 is 5. So I have 3 to the 5th power, which is, so here cube is 27. So I have to multiply 27 times 9, technically, which is 243. So my next term is 2, 4, 3. And then we have one more term to calculate. So we have 3 with exponent 2 times 5 minus 3. 10 minus 3 is 7. So I have 3 to the 7th power is going to be, this is how I'm doing it easier. So 3 to the 5th times 3 squared, which is 9. So I have to multiply the previous number by 9. That's actually what I'm doing. So when I multiply by 9, I'm going to get 2001.87. So that's my next term. 2001.87. So here it says find the sequence. So we're just going to list all these numbers. So these are my answers. You're going to list those numbers. You're not going to add them. You're just going to list them. So the answer is 1/3, 3, 27, 243, and 2187. So that's how you do number one, and this is how you show your work. Okay, you can just type it in or write on it, whatever it's easier for you. Okay, the next one, we have to find the general term. So this type of questions is where you have to kind of analyze the problem and find the formula. So here we're going to start with looking at each number individually. So we have 9, 25, 49, and 81. So 9 technically is 3 square. And then the next number is 5 square, right? Is 25. And the next one is 7 square. And then 9 square. So here we have what type of numbers? We have all the bases 3, 5, 7, and 9 there, odd numbers. So we have odd number with exponent 2. So here we have to see how we're gonna find, the formula should be an equals, and you're gonna have something in terms of n, and it's gonna be square. So now the question is how we're gonna get, so when n is 1, you have to have formula which give me 3. When n is 2, I need to get 5. When n is 3, because the third term is 7, and when n is 4, I should get 9. So let's see. So 1, how from 1 we're going to get 3, and it's an even. All of these are even now, odd numbers. So I can say that 2n plus 1 is going to give me 3, right? And 2, because 2 times 1, so this is what I'm thinking is going to be 2n plus 1 usually give you the 2n plus 1 give you odd number, 2n give you even number. Remember that. So this is always odd number. And these are the numbers 3, 5, 7, 9, the odd numbers. So here we have, when I plug it in 1, 2 plus, so that's 3. Let's check the next one. 2 times 2 plus 1, is it 5? Yes. Now I have 2 times 3 plus 1, is it 7? Yes, it is. 2 times 4 plus 1 is also 9. Okay, so this is how you're gonna rewrite. This is how you're gonna get your general form for this sequence. So it's gonna be an equals, and I'm gonna put 2n plus 1 with exponent 2, with power 2. So this is my general term. This is my answer. And when I replace n with 1, 2, 3, and so on, I'm gonna get the terms I have given here. Okay, so let's go ahead and look at the next one. The next one is the same idea we have to think about. Look at the numbers, what we have, and then let's see how we're going to find the general term here. So looking at 64, 216, 512, 64 is, let's see what it is. Is it cube, 4 cube? Oh no, I'm sorry, let's start with 2. 2 cube is 8. That's where you start, 2 cube. The next one is going to be 4 cube is 64, because 4 times 4 times 4 is 64. And then the next one is 6 cube, because 6 times 6 times 6 is 216. And when you do 8 cube, you're going to get 8 times 8 is 64, times another 8 is going to be 512. So this is how your sequence looks like. So when I rewrite the numbers like this, you see that they're the same numbers. So now let's see how we're gonna get the formula. So the formula should be an equals, and looking at my sequence, all the numbers are gonna be cubed, right? Because all of those numbers are cubed. So now let's think about how from 1, 2, 3, 4. So I'm gonna just split this. So n is 1. I need to get 2. N is 2, I need to get 4. N is 3, I need to get 6. and n is 4, I need to get 8. So I told you when it's odd number, usually it's 2n plus 1 minus 1 or something like that. When it's even number, so all these numbers are even, usually they're represented with 2n. So 2n is even, or 2n plus 2 or something like that. So now when n is 1, I can do 2 times 1 is 2, right? When n is 2, 2 times 2 is 4, so that works. 2 times 3 and 2 times 4. So my formula looks to work. So 2n, it's a good number to put in my general term, 2n with exponent 3. And this is going to give me the formula to calculate each number in that sequence. Okay? So that's how you do this type of questions. So look at each number individually, see what it is, and then represent it with the formula. Okay? Then you're going to go to the next one, which is number 3. We have the following sequences recursively defined with the indicated basis and recursive relation defined for n is greater or equal 1. Give the first 6 terms. So here we have to find the first 6 terms of this sequence. That's what you need to do. Okay? So we already have A1. A1 is the first term. So what you need to do is you need to find A2 and so on using this formula. So n is 1, so we have A1 is 5, the first one is 5. Then you have to find A2. A2 is going to be when n is 2, right? So I'm using the given formula here, this one, and I'm going to replace n with 2. So I have 3 times 2 plus 1, and then multiply by a, 2 minus 1 is 1. So I'm going to have 2 times 3, 6 plus 1, 7. A1. What is A1? A1 is 5. So it's going to be 7 times 5, which is 35. So my next one is 35. So that's the second term. Then I'm going to go to do an A3. And A3, I'm replacing n equals 3. So I'm going to write it like this. 3 times 3 plus 1 multiplied by A3 minus 1, which is technically the previous one, 35. 3 times 3, 9 plus 1 is 10. A2, and A2 is the one before, so it's going to be 10 times 35. I'm going to get 350 is my next term. So I have 3 of those numbers. Then I'm going to go to the next one, A4. I'm going to replace n with 4 now. So I have 3, 4 plus 1, multiplied by A4 minus 1 is 3, and A3 is this one here. So we're working with the numbers before. Okay? So we're going to get 12 plus 1 is 13 times 350. And we're going to get, what is that? 350 times 13 is, it's a big number, 4,550. Okay, that's A4. Then you're going to find A5 the same way, replacing n with 5. You have 3 times 5 plus 1 multiplied by A. 5 minus 1 is 4. So you have 16 multiplying by 4,550. And it's going to be another big number. Times 16. 72,800. And I need one more, A6. And A6 is replacing n with 6. So we have 3 times 6 plus 1 times A5. And that's 18 plus 1 is 19. Multiplying by the previous number. And we're going to get 1,383,200. Okay, so these are my 6 numbers, and you can just list them. Okay, I stopped listing them here because I don't have enough room, so I'm just gonna write them down here. So the answer is, this is my final answer. The sequence is, or I can just write it like this: 5, 35, 350, 4,550, 72, 800, and 1,383,200. And these are my answers. This is my sequence of the 6 numbers. Okay, so that's how you do these type of questions. You just plug it in and just recursively use the previous term. Okay, the next one is number 4, where you have to calculate the sum. N is changing from 2 to 5. And this is the formula how to calculate each term. So here we can, we did this in algebra. We can make that little table where you make n is changing from 2 to 5. Two, 3, 4, and 5. And then the formula is 2 over 3 to the n. So we have 2 over 3 squared. The next one is going to be 2 over 3 cubed, 2 over 3 to the 4th, and 2 over 3 to the 5th power. And you're going to add those numbers. So what you need to do is add those numbers because it says sigma, find the sum. Find the sum. So you're going to add all these numbers. Now, these are big fractions, and what you can do, you can use symbol up for here. Okay, so I'm going to open symbol up. And here you go, you can just enter that. So you have fraction, and you do 2 over 3, oops, sorry, 2 over 3 square. Then you have, just enter it the way it is, plus 2 over 3 with exponent 3, plus 2 over 3 with exponent 4. Oops, sorry, 4, not 2. And then plus 2 over 3 with exponent 5. So just enter it the way it is. Enter your the sum, and then the answer is use the fraction 80 over 243. And that's my final answer. When you add all these fractions, this is what you're going to get. Okay, and use your calculator. So the next one is number 5. We have for the phone sequences, determine whatever they are arithmetic. If they are arithmetic, determine the common difference. If they are not arithmetic, we need to explain why they are not arithmetic. So this one, we have to, what the arithmetic sequence is. From number to number, you're adding or subtracting the same number. And that's called the common difference. Okay, so let's see what's happened here. So starting from 3, negative 3, if you want to go to 0, what you're doing, you're adding 3, right? Then from 0 to 3, you add in 3. From 3 to 6, you add in 3 again. So what's happened? You add in number in this sequence from number to number, you add in 3. So the answer here is yes. It's arithmetic. And what is the common difference? Usually the letter D is the common difference. It's gonna be the number 3. Okay? So that's how you solve this one. You need to write the common difference, and you have to check if it's arithmetic or not. So let's go ahead and do the next one. The next one you're going to do the same way. So start number to number. From 2 to 6, you need to add 2. Now from 6 to 9, what you adding? You adding 3. 6 plus 3 is 9. Now from 9 to 13, what you adding? You adding 4. Okay, so here there is a pattern. You can tell what's going to be the next number, but they're asking, is that arithmetic? No, it's not arithmetic because you're adding different numbers. It's going to be not arithmetic. Just going to explain it with your own word because you're adding different numbers. Just explain that with your own words because you're adding different numbers. Okay, so that's it. Make sure you just type it in, explain why you think it's not, because you're adding different numbers, not the same numbers. So that's how you do this one. And then we have number 6. We have to do something similar, but here we're talking about geometric sequence. So we have to check if they're geometric or not. And in this case, something is geometric when you go from number to number, you multiply by the same or divide by the same number. Okay? And you need to find a common ratio if it's arithmetic. If not, we have to explain why. So let's look at the first one. So from 1 to 3, what you're multiplying by? You're multiplying by 3, right? Then from 3 to 9, to get 9, you're going to multiply times 3 again, right? 3 times 3 is 9. Then from 9 to 27, you're going to times 3 another time. 3 times 9 is 27. So obviously this is yes, it's a arithmetic, it's a geometric. And what is the common ratio? We're using the letter R. It's going to be the number 3. You're multiplying each number. Okay, so that's number 6, the first one. And then let's go ahead and do the second one. So here we start from 0 to 2. What you're multiplying to get 2. Whatever you multiply, if this is 0, you're going to get 0. So this is not geometric. Why it's not geometric? Because it's not geometric because the first term is 0. So if you multiply 0 times anything, is going to be 0, and it's not going to give you geometric sequence, okay? Because the first number is 0. So just type it in with your own words why you think it's not geometric. Because the first term, because of this first term, is 0. You can't have 0 there, okay? So that's number 6. Then you're going to go to number 7. And in number 7, it says in this problem, the first term and the common ratio of geometric sequence is given. Find the first 4 terms. So you have to find the first 4 terms of the sequence. And also the 10th term. Okay? So here we have a geometric. We know it's a geometric sequence. So here we're going to use the formula for geometric sequence. So looking at my formula sheet, remember the geometric sequence? So this is the formula we're going to use. So if I want to find the first, the second, and the third, I know I'm going to multiply by the same number. But if I want to find the 10th term, I'm just going to replace n with 10, and I'm going to get my 10 term. I don't need to go all the way to 10. I can just use this formula. Okay? So let's go ahead and do the first 4. So we already have A1. A1 is 9. Then the common ratio is 1/3. So that means I'm going to multiply by 1/3, by 1/3, by 1/3 is going to give me the next term. So if the first one is 9, the second one is going to be when I multiply 9 times the common ratio is 1/3. I can reduce that. It's going to give me 3. So the second term is going to be 3. And then I'm going to find the third one. Is going to be I multiply the number I get 3. I'm going to multiply by 1/3 again. And here 3 and 3 cancel, so it's going to be 1. So that's my third one. And then I'm going to do one more. I need to find one more, A4. So I'm going to get the previous one, which is 1. And I'm going to multiply by 1/3. So here nothing cancels, so my answer is going to be 1/3. So the first 4 terms are 9, 3, 1, and 1/3. So these are the answer for the first 4. And now I have to find the 10th term. So here I'm going to use the formula. So I have A10 is going to be A1. See, this is the formula again. A1 times R with exponent n minus 1. So I have A1 is 9 times 1/3 is my common ratio with power 10 minus 1. And I can just simplify this using Symbol Up. I can just put it here. So I have, what was that? Let me see. Oops. We have 9 and 1/3. Okay. So I have 9, 1/3. And then I'm going to put power, 10 minus 1. Or you can just put it 10 minus 1, or you can just put power 9, doesn't matter. And we're going to get the fraction. So it's going to be 1/2187. So it's going to be 1/2187. And that's my final answer. This is my answer for the 10th term. Okay, so that's how you do number 7. Then we're going to go ahead and do number 8. So number 8, it says in the following problem, the first few terms of geometric sequence are given, so we know it's a geometric. Find the common ratio and then find the 9th term. Okay, so looking at my sequence, I have the first term, A1, is 5, because that's the first term, right? Now the common ratio is when you divide 2 consecutive terms. Okay, so I can divide 7.5 divided by 5, or I can divide 11.25 divided by 7.5, doesn't matter. Or I can also divide 16.875 divided by 11.25. So all of these divisions should give me the same number, because that's what the common ratio is. When I divide 7.5, when I divide it by 5, it's going to be 1.5. When I divide 11.25 by 7.5, it's also 1.5. When I divide 16.875 by 11.25, also is going to give me 1.5. So this is the property for common ratio. So the common ratio is 1.5. Then we have to find the 9th term. Just double check 10. Okay, the previous one was 10. Here we have to find the 9th term. So we're going to use the formula for A9, formula for geometric sequence is going to be A1, which is 5, and then the common ratio with exponent 9 minus 1. So this is what you're going to simplify. And I can use here simple up. So this is 9. This was 1.5. I'm just changing, and that was 5. So just plug it in there, and you're going to give you, that's going to be the 9th term. Hold on, let me. So we're going to get 128.14. I'm just going to round 145. So we're going to get 128.145. Okay, so that's the answer for the 9th term. Okay, so that was 8, and then you're going to go to number 9. And in number 9, we have to, let me move it. Okay, number 9, we have to find the sum of the given geometric sequence. So this is a geometric. We know it's a geometric. So you can do it 2 ways. You can write it like expand it. N is 1, 2, 3, and so on, and put it like that in symbol up. Or you know that this is A1. This is the common ratio. And N is 8, right? So you can just put it like that. Okay, so let's go ahead and because you have the sum, the formula for the sum. See, this is the formula. So the geometric formula for geometric is right here. How to find the sum of the first 8. You have A1, 1 minus the common ratio. So using this formula, you have 8 here, A1 is given, and this is given. So this is the formula you're going to use. Okay, and I can just, let's do that. I'm just gonna copy this formula, and you're gonna use this formula for this one. Okay, so I'm gonna show both ways. You can do it with, you can expand it and write it down, or you can use this formula. Okay, so if I use this formula, I'm gonna get A1 is 1/2, and then you have 1 minus the common ratio is also 1/2 with exponent 8, and everything over 1 minus 1/2. So I can just put this in my symbol up. It's faster to plug it in than expanding it. So when n is 1, it's going to be 1/2 times 1/2 to the power 0, which is 1. Then you have plus 1/2 times 1/2 to the power 1, okay, plus 1/2 squared all the way to 8. So it's a long way of plugging it in the calculator. If I use this way, it's going to be faster. So that's what I'm going to enter in my symbol app. So I'm going to do it like this. I'm going to start with fraction, and I have 1/2, and then parentheses 1 minus 1/2 with exponent, what was that, 8, okay, exponent 8, and then in the bottom you have 1 minus 1/2, like that. So just enter it in this way. It's easier than expanding the sum. And we're going to use the fraction form, 255 over 256. And that's how you get it. Okay? And here's number 10. So for number 10, I'm going to explain how to do it, and here you have a little notes included in this practice quiz so you can use them. So let me explain what that means here. What is this problem about? So Maya is planning to save for retirement. She figured that she will live 25 years after she retires, and it is 30 years until she retires. So here you just have to look at this. It's like a graph. So this is now, this is the time when she retires. So this is the year she retired. And then this is the time she passed away. Okay, everything is calculated. So she's gonna live 25 years after she retires. So this time is 25 years. And the time till retirement is 30 years. Okay, so this is now, this is when she retired, and this is the end of her life. Okay, she wants 50,000 the first year of retirement. So after she retired, she wants the A1 to be 50,000. Okay, then 5% more each year. So that means the rate, because it's increasing every year with 5%, is going to be 1.05, because that's the increase every year. She plans to save in, so now we're talking about how much she's going to save. We're talking about right now. Okay, she plans on saving. So this is when she saved the money for retirement, and then this is when she spent the money. Okay, so keep that in mind also. So she plans on saving the first year. So we don't know how much she's gonna spend. She's gonna save. So we don't know how much she's gonna start with, the savings. And 6% more each year after that. So that means the rate is gonna be 1.06, because 6% in decimal is 0.06, but it's add up to the 100% pretty much. That's how you look at it. So it's gonna be 1.06 every year after that. Okay, so we're not gonna look at the interest. How much Maya have to save the first year? So that's the question here. How much she needs to save the first year? Okay, and actually I should do that. Sorry, let me write it here. I should do that here. So this is the information, and we have now. Oh, sorry, I should do that. So I have now retire, and this is when she. So this was 30 years. This was 25, and we have A1 here is 50,000. And the rate is 1.05, and here that's what you need to find the first year, how much you need to save. These are her savings, and after that she's gonna spend the money, right? And this is now, and the rate here is gonna be 1.06, because it's 6% increase in every year. Okay, so we have everything we need. So what you need to do, you need to find A1. And this, I put the steps here. The first step is we need to find the sum. We need to see how much money she needs. And we're using S25. So these are the steps. First step is we need to find S25. with this given. We're going to find how much she needs to save. And then after that, we're going to find A1 using the formula. This is the formula you're using down here. And we need to find A1. Okay, so these are the things given, and we're going to find, use the calculator to simplify it. So first we need to find S25. So we need to find how much she needs to spend. So we need to see how much she needs if she wanna have 50,000 first year and then increasing every year. So now we're talking about finding S25 here. That's what you're gonna find first. And then the second step is gonna be finding A1 on her savings side. Okay, so let's start with S25. So the first step, and that's what you're gonna put in the calculator. S25 is gonna be A1 is 50,000. And then you have 1 minus the rate is 1.05 with exponent. Now here, how many years we have? 25 over 1 minus 1.05. And then we're going to plug this in the calculator and we're going to get the number. So let's use calculator. So we have fraction 50,000 parentheses 1 minus 1.05 with exponent 25 over 1 minus 1.05. So let me double check the numbers. Okay, 50,000. Okay, everything is good. And this is the amount she needs to get. She needs to retirement. And I'm just going to copy this number, and it's going to be 0.94 because now after 94 is 0. So I'm copying in this. I'm just going to copy this number, and I'm going to put it, oops, sorry. I'm going to put that answer here. So this is how much she needs to save. And so this 2 million and so on, right? That's how much she needs to save. So that's my first step. And this is what you're going to put in your calculator, and this is the answer for the first step. Then the second step is you have to find A1, and it's going to be here, it's going to be the number we just get, which is 2 millions 3 8 6 354.94, and then we have 1 minus 1.06 with exponent 30. I'm sorry, it's backwards because it's divided by. And then over 1 minus 1.06 with exponent 30. So that's what you're going to put in the calculator. And then you're going to get your, how much she needs to start saving the first year for retirement. So let's use that calculator. So I'm going to copy this number here. Okay. And then I have 1 minus 0.6. And this is 0.6 with exponent 30. Okay, so that's my, oops, hold on, this is not right, 0.6. So have this number copy 1 minus 0.06, and then the exponent 30 is in the bottom because we're looking for A1. And then this is how much he needs to save. Now I'm gonna copy this answer again, oops, sorry, 30,000 184.79 because after the 9 is 2, so it's not gonna change it. And the first year she needs to save, I'm gonna just put this number here. So I'm gonna copy that. So the first year she needs to save, so that's the answer actually. So A1 is, that means the green one. A1 is, oh, I copied the wrong one. Hold on, sorry. That's not the one I'm looking for, see? I need to copy this. Control C, it doesn't work. Let's see. Okay, there you go. 30,184.79. So that's the amount she needs to start saving the first year, and then increase it every year with 6% to get to 2 million and something. That's how much she needs. And then she's gonna start spending that money for 25 years, and she's gonna increase. So the first year for retirement, she's gonna get 50,000, and then after that, every year she's gonna increase with 5% her retirement for every year. Okay, so that's the answer. So that concludes pretty much the quiz 3.